Good morning. We are Group 6 and we will be explaining the Nvidia GPU. Next slide, please. So our agenda for today is simple. I will be introducing the Nvidia GPU. Ben will be telling us its creators and its brief history. Ryan will be showing us how it works. And then Anton will be showcasing us the implementation of the technology. Next slide, please. So for the introduction, Nvidia GPU are high-performance graphic cards that are hardware devices which allow modern computers to have the ability to render graphical resources, to process multiple data at the same time, and to utilize computer operations, such as running gaming applications, editing videos, and performing machine learning. These graphic cards have been widely used not only by personal users, but also large companies that need strong resource processors on their technology, such as companies that host a large server, companies that host a data mainframe, or companies that pursue the field of deep learning, which requires a lot of parallelized processing cores. These graphic cards, as its name states, originated from Nvidia Corporation, which is also known as being one of the main driving forces in the creation of high-performance graphics processing hardwares, alongside other rival companies such as AMD and Intel. One of the special aspects that differentiate these GPUs from others is its inclusion of an API known as Compute Unified Device Architecture, or CUDA for short, which allows the utilization of high amounts of parallelized processing cores, allowing the more efficient implementation of deep learning software and machine learning algorithms. Next slide, please.
Okay, so the creators of Nvidia were three people: Jensen Huang, Chris Malachowski, and Curtis Priam. They formed it on April 5, 1993. Malachowski and Priam were engineers working in Sun Microsystems. They wanted to leave though because there were internal problems within the company. Huang was in a better state since he was a director at LSI Logic. They supposedly met at a Denny's and then formed the basis of Nvidia with the idea that accelerated or graphics-based computing would be the future, specifically with regards to video games. And at first, they didn't have a specific name for Nvidia, but then they just came up. But then they just used NV, which stood for new version, with Nvidia, which was Latin for envy. The timeline goes like this. NV1 was first created in 1995 and it handled 2D and 3D video and included audio processing software. Reduced for the Sega Saturn, but was not entirely successful sales-wise. But it was enough to keep the brand afloat. In 1999, the GeForce 256 was created. It had hardware transform and lighting processing, which allowed it to have CPU-level calculating ability, and it also included video acceleration software. These features will be explained later. GeForce 3 contained 60 million 150 nanometer transistors, which topped up to 250 megahertz. Before, it was only 180 nanometers. And as a result, it also introduced the light-speed memory architecture, the LMA, which was a new memory subsystem that reduced demand on the limited bandwidth. Production, however, was very expensive. GeForce 8000, the series, introduced Tesla microarchitecture, which was the first microarchitecture to implement unified shader design. It also featured support for several things such as Microsoft's DirectX 10 API and Pixel Shader 4.0. The flagship, known as the GeForce 8800 GTX, ended up being twice as fast as its predecessor. Eventually, the Tesla microarchitecture became the Tesla 2.0 and then was replaced by the Fermi architecture in the GeForce 400 in 2010. However, it was incredibly high performance, but it cost a lot because of hardware space, and the technology was also very hot and noisy. Fermi architecture would be replaced by Maxwell and then by Pascal, and then by 2018, the GeForce RTX would eventually be using Turing architecture, which combined real-time ray tracing and AI to enhance video game graphics one step further, eventually leading to virtual reality.
So first, let's explain the basic functions of a GPU. So the graphics processing unit, as its namesake implies, is mainly responsible for rendering the computer graphics as well as its output into the computer monitor. It excels in this purpose by utilizing multiple processing cores that are suited for simple operations to calculate for computer graphics. Since it is catered towards parallelizing floating point and integer operations, it is also widely used in AI and cryptographic calculations. Next slide. To put it into perspective, in terms of graphics processing, a computer monitor consists of numerous pixels, each of them having 3 possible colors, namely red, green, and blue, with each of these colors having a range of brightness that is suitable for rendering a finite set of other colors. Imagine a computer screen that has a resolution of 1080 by 920. Multiply both of these and you will get the total number of pixels that needs to be rendered, which equates to 2,073,600. Multiply this with 3 to get the total number of the red, green, and blue colors that are possessed, and this value comes to about 6 million. Next slide. For a CPU, this involves processing approximately 6 million colors of those pixels with the necessary operations within a certain period of time, and despite of how fast it is in completing complex tasks, it is still restrained by its clock speed and the number of cores that it has. A GPU shines in this regard by using numerous cores to process these colors in the pixels simultaneously, therefore rendering more frames than a CPU could within a period of time. Next slide. So for the next slides, a simple analogy of this as an example can be shown in a scenario where several boxes had to be carried to a certain location. Let's say a weight lifter as represented by the CPU may be able to carry more boxes than a normal person could. So as you can see, it could carry 2 boxes at a time, but it is still limited by how many boxes that could be balanced in its arms, thus needing to go back to get the other boxes. So for the next slide, a group of people as represented by the GPU will be able to finish this task faster, with each of them carrying a single box and carrying all of these boxes all at once in the destination, as you could see in the next slides. There. So as you can see, they were able to get 8 boxes compared to the 2 that the previous CPU had handled. Next slide. So the NV1. Nvidia's first GPU defined the basic aspects that we usually associate to the GPU today, with the feature of a GPU texturing, which makes it possible to apply a texture to a 3D object in a scene while rendering it in real time. In comparison, during the early days of real-time 3D graphics, utilizing a CPU for rendering a textured 3D object means that the output video is more akin to a slideshow presentation, or that it loses the ability to render high-quality textures to make way for real-time graphics. Next slide. The second major update in Nvidia's lineup implemented the idea of unified shader model through their Compute Unified Device Architecture, which combines the vertex shaders, the ones that renders the shapes, and pixel shaders, which are the ones that renders the colors of a pixel, into a core that could process both. This in turn leads to less downtime of the shading cores, thus improving performance as well as efficiency. Next slide. The third major update in Nvidia's recent history is the capability to render pseudo-realistic light rays in real time through the usage of ray tracing cores, as well as AI, which aims to speed up the computations by downscaling an image, and then guessing the characteristics of the low-resolution image through the usage of dedicated tensor cores to upscale the inferred image. Next slide.
I will be discussing the implementation of technology, or in this case, the implementation of NVIDIA GPU. Next slide, please. The first would be, in my opinion, is the most popular one, would be NVIDIA GeForce. This is needed in the owner's personal computer if their task is to edit videos, play games that have high graphics, and for scientific visualization to represent raw and scientific data as images. The Nvidia GeForce has different series, with each of them being an improvement of the previous one. From the oldest to the newest, we have the RTX 20 series, the GTX 16 series, RTX 30 series, and then the RTX 40 series. Next slide, please. Now let's discuss about the ones that are not very popular to the public, because all we think of Nvidia would be games and video editing, but there are also more, like Nvidia Clara, which is for healthcare. So the healthcare industry would need new computer paradigms to meet the requirements of customized medicine, next generation clinics, increased quality of core, and discoveries in biological research to treat disease. So with Nvidia Clara, it utilizes both the power of AI and high performance computing, which is for the drug discovery, which models millions of molecules and screens hundreds of potential drugs at a time. Genomics, or the study of genes, which accelerates genome analysis in population and cancer genomic studies to help identify rare diseases. For medical devices, to detect and measure anomalies, up-level surgeon skills, enhance visual image quality, and optimize workflows. And the last would be smart hospitals, which is to deliver immediate insights and optimize patient care, with examples being smart sensors and advanced image processing. Next slide, please. Another one would be Nvidia Metropolis. Like Nvidia Clara, it also utilizes AI, but this time it also now includes visual data to increase operational effectiveness and safety across a variety of sectors, which includes smart cities. This is to maintain and upgrade the city's parking lots, structures, and public services, like intelligent traffic systems, access control, public transit, and smart buildings. It also includes retail and logistics, which boosts business efficiency, in-store analytics, and customer pleasure through frictionless checkout, loss prevention, truck and goods routing, and inventory management. And then there is industrial and manufacturing to enhance industrial inspection, boost output, and save waste on production lines through automated optical inspection, preventive maintenance, remote asset monitoring, and safety and compliance. And the last would be healthcare. This enhances operational effectiveness, ensure public safety, and improve patient care at healthcare facilities through temperature screening, PPE detection, patient monitoring, and surgery analytics. Next slide, please. So there are a lot of implementation of the Nvidia GPU, like the Omniverse for metaverse applications, driving for self-driving vehicles, Maxine for cloud AI video streaming, Rive for speech AI, Rapids for data analytics, Merlin for recommender system, Isaac for robotics, and Ariel for telecommunications. Next slide, please. And that is about the end of our presentation. Here are the references that we have used for this discussion. Next slide, please. And thank you all for listening, and have a good day.